Welcome back, everybody. We are continuing our notes in section 2.1, talking about transformations of our parent quadratic function. And remember, that can be f of x is equal to the parent function x squared. Our next transformation is going to be reflections. For now, we're going to reflect over the x-axis. That's adding a negative in front of our parent function. And it flips our graph upside down. Sketching a graph of our parent function. Here's a sketch of our parent function. And if we reflect it, it's going to look like this. Just flip upside down. And the reason why that's happening is where the negative happens to be changes the signs of our y values in the ordered pairs. We're also going to talk about vertical stretches and shrinks. A vertical stretch is when our a is greater than 1. That's this number in front of the x squared, and you must make sure we're not in any parentheses here. So it can't look like this. It has to be the way that it is. And so when we're stretching something, that means we're taking the arms here on our parent function and we're pulling them upwards. If we are shrinking something, then that number in front of our parent function is a number between 0 and 1. Now, I know we want to say fractions, but remember, fractions can be bigger than 1. 3/2 is bigger than 1. So this shrink is shrinking by 1/4. And when we shrink something, we're again taking the arms of our parabola and the parent function and we're pushing them down. Stretching kind of makes our parabola arms come closer together, while shrinking kind of pushes them down towards the x-axis. When we're trying to figure out vertical stretches and shrinks, basically what we're doing is multiplying our y values on our t-table by whatever that a value is. Let's try some. Pause right now if you need to grab your graph paper and any colored pens or pencils if you're showing your transformations in colors. Negative x squared is our x-axis reflection. So our parent t-table, this is our parent function of x squared. Remember, we're -2, -1, 0, 1, 2. And so this reflection makes these the opposite sign. Since these are all positive, it changes all of these to negative. Now remember, 0 can't be positive or negative, so that just kind of stays the way that it is. If I make our graph, don't forget on your graph to make sure that you label so we know what your scale is. I'm going to sketch my parent function here with my dotted line. Then I'm going to plot my transformed one using our new ordered pairs. So -2, -4, -1, -1, 0, 0, 1, -1, and 2, -4. And here you can see then that it took our graph and flipped it upside down. Example 2. We are stretching it vertically. It's a stretch because 3 is greater than 1. I'm again going to take a look at my parent function t-table. We're using the same one every single time. -1, -2, 0, 1, 2, 4, 1, 0, 1, 4. I don't know why this 4 doesn't want to write. Sorry about that. And then remember in the notes on the previous slide, we said that to make a stretch, we're multiplying our y values by 3. So we still have -2, -1, 0, 1, 2, but 4 times 3 is 12, 1 times 3 is 3, 0 times 3 is 0, 1 times 3 is 3, and 4 times 3 is 12. Sketching our graph. I'm having issues writing today. All right, so I'm going to graph our parent function first. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And here's our sketch. And then in green, I'm going to graph our new one. -2, 12, -1, 3, 0, 0, 1, 3, and 2, 12. And so this green one is our graph. Okay, on your example 3, you're missing this 1/4. So if you would go ahead and put that 1/4 in on your paper. We have the negative in front, which is our x-axis reflection. And then our 1/4, which is a vertical shrink. Now remember, this is a shrink because 1/4 is between 0 and 1. And last but not least, we have down 2. If I look at my parent function, again, x squared, oops, 41014. We work our transformations from left to right. So furthest to the left is our x-axis reflection. I'm going to note that with red. And remember that says take our y values and make them the opposite sign. So now these become negative. To do our vertical shrink, we're taking our y values and multiplying them by 1/4. So our x values, remember, are not changing. -4 times 1/4 is -1. -1 times 1/4 is -1/4. 0 times 1/4 is 0. 1 times 1/4 is 1/4. And -4 times 1/4 is -1. Our last transformation is to take all of those and go down 2. So I'm going to wait until we get onto our graph to be able to do that. And I'm actually going to pause for a second and add a slide to do our graph. This time I'm not going to graph that parent function. I'm going to start with the last table that we made. And so the last table that we made had -2, -1, 1, 1/4. So it's going to be super close here to that x-axis. 0, 0, 1, -1/4, and then 2, -1. And our last step then is to slide all of these down 2. So 1, 2. Oops. I'm going to change that color into gold here. 1/4, 1, 2. 0 goes down 2. 1/4 down 2. And then down 2. So you can see that this 1/4 made our parabola really, really wide. Okay. What I'd like you to do for tomorrow is try to graph this fourth transformation. Bring your graph in along with your notes, and we'll see you tomorrow. Have a great night.